Over to you, Sachin.
Thank you, Leo. So it's my privilege to talk to you about a project we have been working on for the last 5 years called Digital Pacific, where we're trying to use Earth observation to solve some of the most challenging issues facing our small islands and atolls in the Pacific around food security, water security, climate change, and national resource management. So I work for SPC. SPC is the principal scientific and technical organization in the Pacific. We were formed in 1947 in Canberra, and we owned and managed by 27 members and countries. So all the way from very large islands like PNG with 10 million population to small islands with 9,000 people like Tuvalu, who are on the forefront of sea level rise and climate change. And we have about 1,000 staff with an annual budget of 100 million USD. So what is the gaps that the Pacific is trying to solve? As you know, of our region, there's been fortnightly capture from Landsat and Sentinel over the last 3 decades. But unfortunately, we don't have the capacity, the infrastructure, or the skill sets to actually utilize this Earth observation data to the fullest. So Digital Earth Pacific is built to bridge the gap and bring us to one-to-one parity with the likes of Australia, Europe, and America. So in essence, it's a cloud-native public good EO infrastructure. Public good in a sense that it's really available to everyone, not just the Pacific Islanders. And the idea is for the system to generate information, reliable products in the past and also in the future to help us with decision making. And I would say 50% of the focus for Digital Pacific is around capacity building. So we do a lot of capacity building across countries. So it's a large-scale compute running on a variety of services powered by AWS and Kubernetes. On the user side, we have the Jupyter Hub environment, where we have standard environments up to like 250 gigabytes CPU, but we also have GPU environments for comprehensive machine learning workflows. And we're quite happy with the infrastructure because it enables us to scale to tens of thousands of CPUs and petabytes of RAM to do regional scale analysis on the fly within a couple of hours. And mostly powered by open data cube libraries and PNGO, things like PyStack. We also use open data queue OGC services to expose a lot of our web services and also GeoServer, but we're slowly migrating from GeoServer to ODC, AWS. And Teria is our front end for visualization. For our users and capacity building, we use Jupyter Hub and some abstraction libraries like DevTools and DeepAL, which I'll talk about later. And then for scaling up, we have Argo and everything's in the stack. We've moved away from PostGIS, so everything's hosted in the stack catalog. That's too much text here. But the point here is that using Python for Earth observations can be really complex, right? When we go for a week-long workshop, we can't spend the whole week teaching people how to use X-ray or GeoPandas or Rio or whatnot and stack. So, and most of these people are decision makers, so they don't have much experience in Python programming. So we have to come up with abstractions where they can do very advanced level stuff with very few lines of code. And it has a very low barrier to entry. So we have 2 of them. One is focused on regional scaling. So if you want to do products on a regional level, we use DevTools, which is an inbuilt searcher, a loader, a processor, and a writer for stack items and cloud storage, and a tags aggregation. So it enables us to like really quickly move from prototype stage to production stage quite easily using DevTools. For localized analysis and prototyping and workshop environments, we use DeepAL, which enables people to do like NDVI in 3 lines of code, right? They can define an EOI by administering the boundaries, and they can generate things like land cover, and they can do change analysis without learning much Python. So we try to keep them evolving these tools so that they can do very comprehensive geospatial remote sensing analysis without writing too much code. And it's an ongoing thing for us. And those are the links if you're interested. So at the moment, we have 9 regional products from coastlines for all our islands and atolls going back 3 decades. We have mangroves, which is very important for climate resilience. We have water observations for space. We have GeoMed, where we build a lot of our ML applications on top of. We have satellite-derived bathymetry, depth up to 30 meters. We have vegetation height, height of vegetation across all islands up to 30 or 40 meters. And we have fractional cover that we use a lot for disaster response and tracking of frequent changes in the environment. And of course, we have a benthic mapping like coral, seagrass. Most of these projects are products like coastlines, intertidal, and GeoMed and WOFs are basically piggyback on the work that Geoscience Australia and Digital Australia have done in the past. So it's all about providing high-resolution data because because of the number of islands that we have and the countries that we have, we don't always have on the ground traditional stats data, so we need to fill in the gaps using spatial data. And it's all about having a consistent coverage monitoring over time of whether it's land cover, coastline. And with fractional cover, we're now actually looking at real-time monitoring of disaster events like tropical cyclone and flooding and drought. For our premier application is the Coastline Change Project, and we have built a lot of decision support tools on top of that. So basically, you can zoom into any island and you can see the rates of change. So for example, this is 2 meters per year erosion in yellow-red, which means this is the rate of change, and these are the number of buildings and mangroves affected. So you can zoom anywhere to any of the countries, and you can see the impact on the population over a number of years. So it's very good for decision making and non-technical GIS people. Similar, we have a lot of extreme events like coastal inundation and king tides. So using this, we're able to monitor the frequency of events using WOFs and also frequency of droughts using WOFs. We do a lot of value-added services. So using our mangroves, we're able to do blue carbon stock assessment across different countries and also change detection. So we can, the countries are able to report back the potential carbon emissions over time back to COP and other agencies. And these data sets go back to 2017-18 because we're using Sentinel-2, but this will be an annual product that will be updated in the future. Again, like I said, it's not always easy to do this kind of analysis if you are not a programmer or a GIS specialist. So we do a lot of effort, put a lot of effort into building tool sets. Like for example, for the SAM ecosystems, the seagrass and mangroves, we build a custom QGIS plugin where the 4 countries are able to pull in the data, loaded by province level, and able to do like above ground tier 1 stock assessments on the fly without writing code. And also use like load data points to do some kind of like random forest classification on seagrass. Yep. Land cover is an ongoing thing. We don't have a regional land cover product at the moment, but it's really important for mitigating climate change because there's a lot of interplay between climate change and land cover. All the countries are supposed to report back to IPCC about changes in land cover every 2 years, but some of our land cover official land cover maps are quite outdated, going back to 2010, 2006. So with this tool and through our workshops, they're able to update the land cover till date and also go back in time to do things like land accounting, to see what the changes are across the ecosystems. And this feeds into the SDG goals around land and agriculture. Climate, we have a lot of climate models that we work in with. And also downscaling a lot of climate models like ERA 5 and ERA Climate to give us parameters such as rainfall on a monthly cadence, temperature, drought index, soil moisture, going back to 1958 to 2024. And we're using a lot of deep learning tools to like really downscale it. Because if you look at a global model like this, and this is one of the countries, Niue, you can see it's like very coarse to do any fine-grained analysis. So there's a lot of going on in that space. Invasives, there's a workshop on Tuesday, I believe, around invasives and land cover in the workshop where it's a big problem, climate-induced alien species like African tulips, which is really affecting our crops and forests. Yep, last year we trained about 120 people. I think the number is much more. Initially we were reaching up to 50% females targeted, but at the moment we have fallen a bit behind to 40%. But yeah, we have done a lot of workshops and all the products such as mangroves and land cover are co-created. So SPC is not doing it on its own. We go to the countries, we take them out to the field, we collect a bunch of data, we come and train the model, then we go back out in the field to validate the output. So it's an ongoing recycling process that we are collaborating with our member countries. But again, like, it doesn't matter how much point you collect. There's a big problem in the Pacific about enough labeled data points, because if you talk about traditional machine learning approaches, you need a lot of sufficient labeled data points, which we're not able to physically do because of the number of islands and how far apart they're spread. So we have been exploring foundational models. So initially, we did a few experimentations, using IBM's TerraMind, where we're able to just take embeddings and generate a land cover without any labels. However, as of 2 weeks ago, we have access to the newly released AlmoET by LNAI, which embeds a lot of satellite images, including things like terra climate models, world population, elevation, weather. So we don't need to do much post-processing and much analysis. We can just take it as is. And at the moment, we're exploring it for land cover, monitoring wetlands, crop mapping, flood detection, and a few other things. So this is just a quick video, I don't know if the sound is playing, about how our data is used on an international level.
The Marshall Islands to the vulnerability of the Runit Dome as seen on the screen. Through SPC's Digital Earth Pacific tool, we can measure the changes in every coastline in the Pacific over time from satellite. And as you can see from this diagram, coastal erosion around the Runit Dome has progressed by over 12.4 metres over the past 2 decades. This leaves only 10 metres of erosion to go before Pacific Ocean waters will hit the very edge of this nuclear waste site at every high tide. At current rates, this is expected to occur within 20 years if urgent action is not taken.
So the data that we've generated feeds into ICJ, where they successfully made the case that countries need to do more about climate change and sea level rise. So the point here is that Digital Earth Pacific is not just about Earth observations. We're actually building a lot of value-added services and digital support tools so that it can provide more intelligent and timely and trusted insights into some of the areas that are most critical for our most vulnerable countries in the Pacific. And it's an ongoing project. We have 9 regional products, but we have quite a few in the pipeline in research and development. And I guess that's it from me. Yep. So yeah, you can browse our stack and also download the raw data and also log into the hub. It's free to register, and you'll have access to very large compute power for Earth observation work. Thank you.
Thanks. I don't quite have a specific question, but a lot of the stuff you've shown looks really awesome, the data visualizations, all the pictures you've shown us. I guess a lot of your work involves targeting that capacity building side of the project, which might be a departure from your technical background or utilising your technical background. And do you have any comments on that?
Yeah, I mean, like, so... For me, like, I've always been, my team has always been providing a lot of capacity building. So like from 2007, I remember we have been doing a lot of QGIS workshops, a lot of GeoSaver workshops. So it was always our modality. Like, so we are not just about delivering the tools and the data. We want to build the capacity in the country. So yeah, that's our business as usual. And we do a lot of training in open source GIS across SPC, whether it's QGIS for census or whether it's QField for health data collection or population data collection. So yeah, it's part of our business.
Well, I have another question. How do you address the issues about actual resources, computational resources, and network connection in some of these remote Pacific countries?
So can be quite challenging because sometimes when we go and do workshops, we have about 40 people in the room and the Wi-Fi is not always great. So, but because of the cloud-native nature of our tools, it's quite lightweight, Jupyter Hub environment, so they're not actually downloading data, uploading data. However, for some more intensive work, like the mangroves and the seagrass analysis, we build a QGIS plugin where we actually package the data inside the plugin. And then we give it to the countries. And they are not dependent on the internet to solve those challenges here. Yeah, I mean that's what we're doing now wouldn't be possible if it was not cloud native and if you're like downloading a bunch of petabytes of data and terabytes of satellite images. Yeah.
Okay, thank you very much, Sachin.